Hello everybody. Today I'm going to go over some techniques for modeling terrain. So we're going to go over how to import real life terrain data into Rhino to begin working with it. And then I'm going to show you guys how to start manipulating those terrain surfaces to create things that you want, as well as maybe some ideas for how to generate terrain from scratch. So there's two main programs that we're going to use today for gathering real-life terrain data and importing into Rhino, and those are SketchUp and GIS. So SketchUp is really good for sites that are maybe at the neighborhood scale or the city scale, something a little bit smaller in nature, while GIS is really good for things that are more regional in nature, large-scale projects and large-scale terrain modeling. So anyway, so I have SketchUp opened up here, a new file here, and so the first thing that I'm going to do here is, let's say we're interested in getting some terrain data and modeling some things on UVA's campus. So the first thing we're going to do is we're going to go to File, and we're going to go to Geolocation, and we're going to add a location. And this will actually place our SketchUp file in the real world. When you open this up, it may be quite zoomed out, something like this. So you'll just have to navigate into the area of interest. So I'm just going to zoom back into Charlottesville. And as you start zooming in, okay, so you see how when I zoomed in, I got a square there. So that's sort of the largest sample size that SketchUp can take, which is why I was saying it is better for like city or neighborhood size things. So we can keep zooming in here, and you can see how that square changes. So if we were to come over here and find the architecture school, for instance, and we were to center that in our sample, then we could select this region, and we can reposition this if we want, so we can make this a little smaller, a little bigger. I'm just going to keep it this square, and we'll go ahead and grab it. Okay, so now you can see we have what basically looks like kind of like a picture sample of the sample that we took, with the center of it being the origin, which for us is the architecture school. So maybe you feel like the size of this is a little bit restricted for you. You want to add a little bit more. Part of your campus that you're interested in is cut off. So even though you can only take one sample size at a time, the nice thing about SketchUp is you can add on to this. So I'm going to go back to geolocation and click Add More Imagery. And it's going to bring up where we were. So let's just move farther over this way. And we'll collect O Hill and that area as well. So we'll select this region too, and go ahead and grab it. Okay, so now you can see that it's basically added that area as well. So you notice this is flat right now, right? If we go back to File and to Geolocation, we can click on Show Terrain, and now you can see that we have an actual live model of the terrain of UVA's campus, taken from, I think it's Google Earth. This says Digital Globe, but something like that. So anyway, so we now have this terrain, and so we can then save this and we can import it into Rhino. So you'll go up to File and Save As, and you can save it as either a 3ds file or a SketchUp file. So if you just save as, you'll get some SketchUp options, but if you go to File and Export as a 3D model, then there's other options for you. So 3ds or SketchUp typically works pretty good. I'm just going to save it as a SketchUp file, And the only other thing that you should remember when saving this is that a lot of times these SketchUp versions are too the versions are too far. They're too advanced for Rhino to take, basically. So a safe way to save this is to save it as version 8, and typically Rhino can take that. But Rhino will tell you if you try to open up a file that's too advanced for it to take. So typically I just do SketchUp version 8 or maybe version 7. We'll go in here and save this as SketchUp Terrain 2. Okay, and then we'll pull it into Rhino. Okay, so we have a brand new Rhino file opened up here, and we're going to go and import our SketchUp file that we just made. So we'll go to File, Import, and choose our file. There are some import options here that you can play around with if you see that the result that you're getting is not what you want. Maybe this weld angle needs to be changed a little bit. I'm going to keep everything like this for now and just hit OK. Typically it works. Okay, and so then if we zoom out, we can see that we have our two surfaces that we pulled in from SketchUp now in Rhino. And if we render this actually, you'll see that it actually also pulled in the satellite imagery from SketchUp and mapped that out on the surface as well. So that's pretty handy. Now if we look at this close, we'll see up here, you'll see that we have sort of two surfaces going on here. We have this flat surface, which is sort of what was showing before we showed the terrain in SketchUp, and then we have the surface that actually has the terrain. So these typically come in and I just get rid of them. Just want to get rid of that one, as well as this one or this second one. Okay, so great. So now we have our surface as two separate meshes. And to get one surface that's consistent, one way of doing this would be the Drape technique, the Drape command. So just go up to the command line and type in Drape. So what Drape does is it's essentially what it says it does. It's like putting a tablecloth down on a bunch of items and then getting the surface that is left after you drape everything over that. So when you so that can be one way of actually creating custom terrain, is if you just place a bunch of kind of objects that can act as hills or can act as ridges, and then to drape over that, and then you get a surface, which I'll show you that here now. So it's asking us to drag a window over the area that we want to drape. So we'll just go ahead and draw a rectangle over, as much of this as we can, as such, and boom. Okay, so now we have a new, we can get to it, a new surface that is kind of like the combined surface of the two separate meshes that we pulled in with. Okay, so you can see that we have that there. And you can actually play around with your drape settings. If I do this again, if I go up to drape, if you go to the spacing, this is kind of related to the strictness of the drape. So whether or not the drape kind of like adheres really strongly to the things that it's going down on, or whether it's looser, it's maybe like a heavier fabric or something, is what you could sort of relate it to. So if I change this and I go all the way down to 1 as a spacing, then what we'll probably see is that we'll get more detail in our drape. So let's go ahead and try that. Okay. So we'll grab our surface, and now if we pull this over, and we go in and take a look at it, we'll see, yes, so we definitely do have more detail, but we actually have a bit too much detail in here. So when we pulled in where we imported the SketchUp file, we imported it comes in as a mesh. so it's a triangulated surface, and we can actually see with this stricter drape that we start to see the triangulation of this surface, which is actually probably not what we want. So we're actually probably going to stick with this initial drape that we did with the spacing of 5. So I'm actually going to get rid of this one. So okay, so great. So now we have this surface that we begin working with, and we could always, we could always keep it over here, and that would allow us to turn on and off the meshes that we had before, so we can sort of reference where things are. But so what do we start doing? What do we do with this now? So things that you might want to get out of a surface like this is you might want to then begin to build some contours off of this that you can manipulate or something. So in order to get contours, we're just going to type in contour, and then it's going to ask us to select the object. So we'll click on the surface we want, and it's going to ask us for the contour base plane point, which is basically the lowest point on your surface, or the lowest corner of your surface. So I'm just going to go over here and click on this, and then it's going to ask us for the direction perpendicular to the surface, or basically the Z direction. So you're just going to go here and click up in the Z direction, and then it's going to ask us for the distance between contours, and I have this set to 100. You could type in whatever. I think 100 is probably going to be good for us, so we'll go ahead and hit enter, and you can see that it's now populating those contours onto our surface, which is great. So wonderful. So now we have these contours. I'm just going to pull them out and show you guys this. Okay, great. So we have our contours, and they're rising and falling in Z space. So this is great. So now I'll show you how to create a surface if all you have is contours. So let's say you pulled in contours from an AutoCAD file. The AutoCAD file you pulled in might have been flat. So you might have to take some time and actually lift these contours up so that they're in the right place. But once you take the time to do that and you actually have your contours in the right place in Z space, we can then make a surface from contours. So and the way we do that is the patch command. And you can either use the patch command with contours, or you can actually extract the points from the contours. And I would actually recommend extracting the points from the contours. Typically, it tends to give me a little better results. Sometimes the edges are really weird when I patch from contours. So let's extract the points. So click on your contours, and we're going to extract PT, extract point. And so now we have all the curve points from our contours, and we'll just pull these over here. And another thing I'm going to do actually is to create just a rectangle around this area, because the next thing that we're going to do is going to require us to trim the surface that we make. So just create a rectangle around your points, and then go ahead and select your points. We'll unclick this guy. Okay, so now we have all these points, and we'll hit the patch command. And it's going to give you some settings. It's going to give you the U and the V spans. So this is kind of like the number of samples that it is going to take in each direction, and so that basically translates to the fidelity of the surface that you're creating. So if you don't need it to be super detailed, then you can lower this. If you need it to be really detailed, you could raise this. I hope this doesn't just crash my computer, but we'll raise it to 100, and we'll try and get something pretty detailed here. We'll just go ahead and click OK. It'll probably do a little thinking here for a second. And that's the other thing to keep in mind is, like, depending on the power of your computer that you're using, you may want to lessen that or maybe want to heighten that, depending. Because sometimes these calculations can just cause your computer to freak out, basically. So, okay, great. So my computer did a fairly good job. Great. So we can kind of see now, maybe if we go into perspective mode, there's a surface here, but it has all these edges, and these are kind of buffers that it puts on just in order to get the calculations right, so that they are correct even all the way out to our sampled edge. So I remember when I drew that line, so I'm now going to extrude that line. Click on it, and we'll extrude it just up a little bit. Basically create this kind of box thing. And I'll just lower this a little bit. Oh, whoops. So it's actually intersecting our surface. And then we'll just trim this surface. So we'll go to Trim, select your cutting object, select the surface that we just created. Great. Okay, so now we've got this trimmed. We'll get rid of this, we don't need it anymore. And then if I move this over, you can see that we have our surface, which we got from the contour points. So great. And something really interesting to do as we do these manipulations is just to look at how much this has changed by going through the operation of taking the contours, then taking the points, and then regenerating the surface. So we can kind of look here and compare. And I see maybe slight lack of detail. There's maybe a little bit of detail loss between this surface and this surface. But mostly it's pretty good. But that is something to just remember. The more kind of calculations and manipulations that you do to a surface, the less fidelity that you're going to get. So what other things can we do with this surface now that we have it? One thing that we can do is to extract one of the isocurves. So we see here, as with most surfaces, we have a number of lines going both in the U and the V direction to create this grid. So we can extract these lines if we want, and I'll show you how to do that and why that's important in just a second. So let's extract isocurve, and it's gonna you can go over here and you can kind of scan down through the isocurve that you want to extract. And right now it's in the U direction. We could change this to the V direction, and then we could scan in this way. So I could, go up to the O hill here and click on this, and then just hit OK, and now I would have basically a section of O hill here, which is kind of nice, as you can see there. But something you can do to actually generate custom or from scratch terrain is actually to make a bunch of these, to make your own sort of like serial sections. So not just take that one that I had, but to make a bunch of these and then spread them out. And then you can do an operation called Loft to create a surface through that. So I'm just gonna pull some lines here, and then we're gonna act like we created them ourselves. So I'm gonna go back to extract the isocurve, and we'll select this. And I'm gonna select all, or I'm gonna extract all in the V direction, and then I'll hit OK, and then we'll just pull these out real quick. Okay, so now you can see we have all these lines, and we're just going to kind of pretend that these were maybe lines that we drew ourselves. So we just had a number of serial sections. Maybe we had a playground that we were working with, and there was a couple different sections that or section conditions that we wanted to create throughout the thing, and we just can then line these together, and then we can grab them all, and then we can loft them, L-O-F-T. and give it a second to do that. Okay, and it'll give you some options here. You can do normal, but there's loose and tight. You can do straight sections, which will give it kind of this faceted look. And I'm just going to do normal. And you can rebuild to change the number of control points. So this all just changes the fidelity of the loft that will be created. But I'll just go ahead and click OK. And it'll make this. And now we have the surface created from our lofts. And we can go back now and we can kind of reference how much it looks like, how much it looks like the surface that we pulled it from. Sorry, I'm a little slow here. Yeah, my computer is whining a little bit about this, but okay. So you can see that there's a little bit of a difference there, but basically this actually looks pretty good, interestingly enough. I wonder how it looks compared to this guy over here. Anyway, I guess that's not super important, but you can just kind of like play around with these different techniques to see how crisp or how accurate they end up, and if you're losing information or not. But you know, this looks like a pretty good surface actually. So so those are just a few techniques. Another technique for manipulating a surface that you might already have is the CageEdit tool. So you can click on this and go to CageEdit, and we'll select our control object, select control object. Typically I just do bounding box. So I click here, and then the rest of these are all typically good. So this is the amount of cage points. Let me just show you what this looks like first, and then we can go back and change this. So basically what you get is a cage with a certain number of points. So we have 4 points in the Z direction and 4 points in the Y and the X direction. And then we can grab these points and we can pull them up, and we can begin to manipulate this surface a little bit. Oh, 1 second, it's thinking. So yeah, so we can just start playing around with peaks and valleys on this surface in this way. And if you wanted to have a little bit more control, then we'll go back real quick. We could type in CageEdit again. We'll select this object, bounding box, and then for the number of cage points, we can increase this. So we could do, 20 in the X. We could do 20 in the Y. Maybe we'll just do 3 in the Z, so we just have a top, a bottom, and a middle. And hit OK with that. Okay, so now we have much more points, and so we can really get in there and do some fine-grained sort of editing. And then when you are done, you can just type in release from cage and select the object that you want. Well, I thought that was going to work. Maybe it's taking a second. Huh. Well, oh, I see. So it's gone. Okay, so then you can just get rid of this cage, and you have the surface back. Okay, so yeah, so those are some techniques for manipulating surfaces or creating surfaces from scratch, from contours. You may actually have point cloud data for a surface that you could then patch and get a surface from. But yeah, so the next thing I'm going to do is I'm going to show you how to pull in a few different techniques that are special to GIS for pulling in regional terrain data into Rhino.
Okay, so as I said before, SketchUp is really good for terrain modeling at the neighborhood or the city size scale, whereas GIS is really good for things at a larger scale, maybe at more of like a regional scale, for instance. So I have here a DEM, or a digital elevation model, that I've downloaded. For those of you who don't know yet, a DEM is just a raster file, a grayscale raster file that goes from black to white. Black represents the lowest elevation and white represents the highest elevation. And by analyzing the gray values, we can generate terrain and all kinds of other information. So I have a DEM here that I've actually clipped. Let me show you, just for you guys to get a sense of the scale difference here. Let me show you. This is the original DEM that I downloaded, which was this size here. If we think back to when we were in SketchUp and we just took a small portion of UVA's campus, if I actually turn on the municipal boundary of Charlottesville here, we can see that it's actually pretty small. It's just right down here. So if we were to zoom in here, we would see that if we were to take a sample size that small, we probably wouldn't get a whole lot of definition, because this DEM is just not really that detailed. Sometimes you'll find ones that are that detailed down to that degree, but I think this DEM is going to be better suited for sort of more of a regional scale. So I'm just going to take a sample of these hills here. So as you can see, this is the original DEM, but then this is the DEM this is my area of interest, so I've cropped this. And I'll show you how to do that now. And basically what you're going to do is you're just going to draw a rectangle over it. In order to crop this, I'm going to turn this off. You're going to go, if you don't have your drawing toolbar up yet, you'll go to Customize, and you'll go to Toolbars, and then to Draw. And this drawing toolbar will come up, and then you'll just select the rectangle tool, and you'll come down in here, and you'll draw a rectangle over your area of interest. So something like that. I'm going to double click on this and just sort of refine this. You can go in and you can change the area if you have a specific area you want. You can change the size. So I'm just going to refine this and actually make this a nice, neat, let me plug in. I'm going to make this a nice, neat 100,000 by 50,000 sample. So let's type in 100,000, yes, by 50,000, click OK. Okay, great. And so yeah, so we can move this around. I'm just gonna kind of position it over the area that the thing that I already took. So right now this thing that we've drawn just sort of exists as an overlay. It's not actually data in a way that we can like use it for analyzing things or for any sort of procedures in GIS. So in order for it to become a shapefile that we can use, we're going to have it selected, and we're going to go to Drawing, and we're going to go to Convert Graphics to Features, and that will convert it to a shapefile that we can then actually use for clipping or other sorts of analysis. So we'll have some options here. These should be pretty good. We'll click OK. It asks if we want to add the exported data to the map as a layer. Yes, we do. So there we go. So now we have this, it's called converted graphics, but it's actually this square, but as a shapefile. So we can still move, you can see we can still move this rectangle anywhere we want. Sometimes I like to put it off to the side, because if I want to take another sample, then I can have the exact same size sample, and I'll just create another shapefile. But for now, we'll just put it off to the side. But then we also have the shapefile that's now embedded embedded and geolocated as a data set. So with this, we can then crop this DEM this larger DEM to something smaller. So if we go to clip, search for clip under data management, and then we'll type in our input roster as our initial DEM. And the output extent, you can use X and Y coordinates here, the minimum X and Y and the maximum X and Y, or you can just use a shapefile like we're going to do. So if we go to converted graphics, which was our shapefile, and click OK, and click OK, it's going to do some thinking. And boom, so now we have this clipped DEM. So if we turn all this off, we'll be able to see. Okay, so this is now our clipped DEM. So great. So now we have our area of interest. And so how do we get it into Rhino? So there's two sort of methods which you can use to pull this information into Rhino and then create an actual surface from it. The first one, which we already went over earlier in the thing, is to create a surface from contours. But first we have to generate contours in GIS so that we can bring them into Rhino. So I'll show you how to do that first. So if we go to contours, let me search, I'm going to click on that. We can use our input raster as this clipped DEM that we just got. And then we can set the contour interval, which I'll just set to 100. You can set the base contour to be the actual lowest contour on your DEM. So if I just pull this off to the side, you see here we have the high and the low values marked for the DEM that we have here, where the lowest value, or the blackest value, is the lowest elevation, so 138 feet above sea level, and then the highest value is 1,177 feet above sea level. So we could set our base contour to be like 138 if you really wanted to do that, and then it would just come in 138 feet up in the air when we bring it into Rhino, but I don't think there's a need to do that for what we're doing here, but you could do that. You can also set the Z factor, which just stretches the contours out or smushes them depending on what you would set this to. But for now, this looks good. We'll just set the contour interval to 100 and click OK, and it'll do some thinking. Great. So now we have some contours that we can work with. As these exist right now, if we were to bring them into Rhino, though, they would be flat. Because when Rhino is looking at the data set that it's pulling in, it's looking for elevation data, and if we were to go into our attribute table right now, we would see that even though this is marked as contour, Rhino is looking specifically for the word elevation, so it wouldn't be able to see that data, and so everything would come in flat. So we actually have to add an elevation field to this data. So we're going to go up to here, and we're going to go to add field. We'll just type in elevation. Click OK. So this has generated an empty field, which we'll have to populate. So we just highlight it and right-click, and we're going to go to the field calculator. And then it's basically asking us, what does elevation equal? Like, compared with the rest of this data, what does elevation equal? And we really just want it to equal this contour. So we have all these contours at 100-foot intervals, and we want that to be read as elevation. So I'll just double-click on this, and now we have elevation equals contour. If you want it to be something else, you could add things together or subtract things, but this is what we want, so we'll click OK. Great. So now we have this populated elevation field. So now that Rhino, when Rhino reads it, it will read the elevation specifically, and it will place that correctly in Z-space. So great. So the last thing we need to do is to just convert this to a package so that Rhino can read it. So the way we're going to do that is we're just going to export it to CAD. So we're going to search for that. And our input features will be our contours. And we'll just click on a place that we want to save this. So I'm going to do this, but I'll do this. I think these old ones are 50, so Virginia Contours 100 is what I'll name this, and save it. This is really important here. Okay, so in order for this to work correctly, both of these need to be unchecked. Sometimes you'll forget to uncheck this, and then you'll bring it into Rhino, and your contours will be all messed up. They'll be all stretched out and in weird places. So just make sure that both of these are unchecked. And then this output type should be fine, and we'll just hit OK. It'll do some thinking. So you'll see that it actually added this AutoCAD package to our map, which you could either delete or get rid of. I'm just going to turn it off for now. So yeah, so now we'll have a file of contours that we can open up in Rhino. But before we get out of here, the other thing that I'm going to do is there's a command in Rhino that's called Heightfield, and what it actually does is it generates a surface automatically and directly from a DEM image or from any sort of grayscale image. We're actually going to save this DEM as an image, and then we'll use that in Rhino as another way of generating this surface. So we can go to File, and we can go to Export Map, and then we can select the file that we want to export this as. I think typically a JPEG is best. I've heard that some people have trouble with the Heightfield command using PNGs, even though that's typically what I like to use. So we'll maybe just do JPEG for now. And then another thing to note when you save this, I'm not going to save it because I already have a copy of it, but is that when you save it, you're going to get this. You're probably going to get this white border depending on your saving options or your saving preferences at the moment. And so you'll just have to go into Photoshop if you do get that, and just trim off the white border so you only have the DEM here. So yeah, so the two things we're pulling into to Rhino from GIS are the contours and the actual DEM as a JPEG file. Okay, so now if we go into Rhino, and we import our contours. Okay. Great. So now we have our contours. You can see from the side view that they've come in with good elevation. They're not flat. So great. From here, what we can do is we can use the same tactic that we did earlier in the video, where we would extract the points and then create a contour from the points. One thing to note about doing this option with GIS is you're probably going to want a pretty strong computer in order to do this. So you can see, you'll be able to see here that there's actually quite a number of points. Maybe my computer might start dragging a little bit. So when you do a patch command with these points, it's going to take a lot of computer power in order to generate that. And I've had my computer die, or not die, but like freak out a few times on me, or the program has crashed, things of that nature. So just remember that when you're pulling these contours from GIS, you're going to get quite a few points. So keep that in mind. You're going to want a pretty high-powered computer when doing this. So, but as I showed you before, you can patch this, and then you can get a surface. But I want to actually show you guys the other way of doing this, which is the Heightfield command. And the Heightfield command uses the DEM that we took, and it creates a surface by analyzing the grayscale values, so analyzing the black and white values of the DEM. So we're just going to click on the DEM, the clip DEM that we had, and we're going to remember how big this was. So I'm just going to draw this to be 100,000 feet, and then it's going to ask us for a number of sample points, and it's also going to ask us for height. And so what we want to do there is we want to go back into GIS and we want to look at the range that we have here. So the low point was 138, and then the high point was 1170, basically 1178. So we want the height to be the difference between those two. That way it's not stretched out further than it needs to be. So I'm just going to do, I'm too lazy, I'm going to do some math here. 1178 minus 138. Oops. So 1040. So that's the height that we're going to want for this. And we'll just hit OK. And if we then go into perspective, and I can render this. It's a bit dark, 1 second. Show you guys, I changed the material here. You'll be able to see a little bit. Okay, great. So now you can see that we have a surface that was generated from that data, which is great. We put under here. Oh, that's not so good. Anyway, so we now have this surface, which was a much easier way and quicker way of getting this than even going through the contours. So that's another really great way of getting a surface if you have a grayscale image. And the other great thing about grayscale images is you can edit them, and then you can get the type of or you can get any type of surface that you want to create. So for instance, I was working in Photoshop, and this is the DEM that I had, but let's say I wanted to create another ridge going this way. So I just simply did like a little copy procedure, but I manipulated this so we have a ridge also going this way. Now, if I were to create a height field from that in Rhino, which we'll just do here, then you'll see that I can then manipulate this grayscale image and then get whatever terrain I want from that. So we'll just go to height field again. This is my edited one. And we'll do 100,000. Click OK. Okay. So now you can see that there is a slight ridge going that way as well. So you could potentially, if you really wanted to be very careful, you could potentially create an entire terrain just by using black and white values in Photoshop and making a grayscale image and then making a height field out of it. So that is one option. But like I could choose a new file here. Well, you get the point. You could just, if I wanted to make a really, really simple terrain, I could just, make some soft, black splashes here and there and blah, 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 and there would be basically like dips in the surface, and then the rest would be white. And if you wanted, to, stretch this taller, we could sort of change the contrast of this and really like deepen the difference between these, and make it like less subtle, or we could brighten this up and then everything would be taller. And so there's a number of different ways you can manipulate this. You can use the tools burning and dodging. So burning is like darkening things. So you can darken this a little bit to lower it, or you could dodge something over here, make this a little lighter. So then you can just start playing with the grayscale values, and then that will help you generate something like this. And then remember that you can also change the height, so if we wanted to exaggerate this, topography for some reason, we could also do that. So instead of doing the appropriate amount, if we wanted to play with this, we could exaggerate and we could make this like 4,000 feet. And then you say that we get some really exaggerated topography over here. So there's a number of, that height field command is really great. And there's also a height field option in Grasshopper if you're using Grasshopper, so you can do that as well. But those are a couple ways of getting surface terrain from GIS. So yeah, so overall, that's a number of ways of modeling terrain, both from SketchUp and from GIS, and pulling it into Rhino. And I'll put a few resources for you guys down in the comments, but otherwise, that's it. Thanks, and we'll see you next time.